Yes, I can see.
Okay, great. Hello, everyone. I'm Vedha Viyash. I live in the southern part of India. I'm currently a senior engineer at Appsilon and have been using R and Shiny for the past 7 years. I love to create large-scale Shiny apps to solve real-world problems. I was fortunate enough to be involved in later stages of some big Shiny apps, which were years in the making, and we got the opportunity to make them production ready. So it was really exciting. Today, I'll share some insights on what I've observed while switching between different projects and working with diverse teams with different skill sets. Uh, but before we start that, any code that we write is just a communication tool between humans and computers. While the computers can only interpret binary, we humans have different abstractions to communicate. The result of these abstractions are different programming languages, and R is just one of these abstractions to help us interact with the computer. So all the R code that we write is converted into binary code that is executed in the computer. A good code serves two purposes. Uh, it should be fast enough for the computer to process it. In other words, if the code solves the problem with a reasonable time complexity for the given problem, it can be deemed fast enough. The second purpose of the code is that it should be easy to read and maintain. Most of today's talk is going to be targeted towards this second purpose. In this illustration, it is seen that most of the team members do not understand how the code works. And this is something we want to avoid. Ideally, the code should be written in a way that is naturally easy for others to understand and contribute. Other members of the team should think that this is what they would do. And generally, these practices are good candidates for good practices that are adopted by the community. When a team uses good practices, they will be in a good consensus throughout the team while building an R package or a Shiny app. Here are a few comments that we can expect from team members when working in a mutual agreement on the code quality. And all of these is thanks to open source packages that help in achieving it. For example, uh, Renv, it's important to freeze package versions. Linter and styler can help the way the code is read by other users. Tidyver styling guide is an important resource to organize your structure of the code. And yes, the code comments should be as minimal as possible. A comment should tell you why something is done rather than what is being done, because the code should be self-explanatory enough to tell you what is being done. This is the reason why I like using function names as verbs, because functions are doing something. And in general, most of the functions also return something. If they don't return something, that is also possible. There are functions with just side effects, but in general, you would want to get something out of a function. So get is a very common verb that is used when creating functions. With proper testing, you can ensure that the app is stable. The users will also be confident in using the app. A good documentation is critical to ensuring new developers can contribute to it. Not just new developers, even you in the future, when you forget things, it will be easy for you to get back. Even a simple CI/CD to just run linters and run tests can help in improving the code quality and help developers focus on important tasks rather than developmental chores. Proper logging messages are very helpful when finding if something is broken. But it's important to not overuse this. Config is where you would customize your application configurations. This is also where you can configure production staging, different types of deployments. Shiny is amazing, I don't think anyone will have any argument against it. Creating a web app with just 4 lines of code is crazy. All you had to do was create an R file with these 4 lines of code. Naming the file app.r also helps during the deployment of this app, as it is the main entry point with minimal configuration. So it's natural to create a single app.r file and start building your Shiny app. The problem arises when the app grows and there are 4,000 lines of code instead of just 4. Unfortunately, this is quite common and it should be avoided. Before writing good Shiny code, we must write good R code. Here we have a code chunk that creates 2 scatter plots. It is clear that there are common elements between these 2 plots. A dry code would be written in a way that has no copy pasting involved, while a wet code is something that's like this, like you copy paste common things and you just use it. To make this into a dry code, we must create a function, nothing fancy. The real challenge is to be able to find an optimal way to create your function that also works in the future when you have changes to the package or function or Shiny app that you're making. For a simple example like this, it's somewhat straightforward. You just create a function, put everything inside it. However, the name myplot does not seem descriptive enough, and you regret not knowing what it does without reading the contents of the function, which is the whole point of renaming it better so that you don't have to go through the extra step of reading through the whole function body. Additional perks to creating a function is that it will allow you to write unit tests. Because functions are isolated components, this can be a single unit of code. The package test that is great for doing this. In the right side, you can see a testing pyramid, which displays different types of automated tests. If you don't have automated tests, your users are the tests. If you're new to test that, don't be overwhelmed because you just need to learn a few handy functions to write your unit tests. All you can see, as you can see, equal and identical assertions are the most common tests performed in the popular R packages mentioned over here. Sometimes the scope of the functions change due to the change that you want to achieve in the package or Shiny app. And please keep in mind that you're better off having simpler code rather than some complex condition that will be hard to recall in the future. And in this case, it's highly recommended not to break them out of these functions or make smaller functions that are used in the code. Just how R code can be reorganized into R functions, Shiny code can be reorganized into Shiny modules. Let's take an example of this app. Imagine that the blue and the orange UI components mentioned over here are drop-down widgets. When the blue widget is triggered, it changes the orange widgets as well as updates the purple plots. When the orange widget is changed, it updates the green plot. Finally, a user can brush the points of the first purple plot to filter the green plot. It is easy to just write all of this logic inside a whole UI and server. However, this will eventually lead to large and unmaintainable code. So using Shiny modules is the right thing to do here. But there are multiple ways to organize your Shiny modules. Each of your widget can be a Shiny module. Technically, that is something that you can do, or you can have it like a sidebar, main bar layout, and just the sidebar can be a module, main bar can be a module, or you could do something that's my favorite, track the reactive uh, objects that are being passed around, and every pass becomes a module. That's very easy to reason in the future. But the best way to organize the Shiny module would depend on the factors like Are there any reusable components in this app that can be identified at this moment? How does the reactivity flow through the app? I highly recommend the talk related to sharing app state between Shiny modules by Machin Dubal during the ShinyConf 2023. Once this concept is mastered, you can instantly become confident in creating nested modules and complex module structures by managing state between them. Let's walk through the case study where we had a Shiny app with a brush of plots, with a bunch of plots and complex file dependencies and hard to interpret code. Our goal was to convert all the static plots into interactive plots and also create similar apps that access different data sources. Finally, we also wanted to update these data sources. Upon investigating the initial app code that was provided to us, it was clear that the author of this code wanted to implement some good practices and have a high quality of the code. There was RENF, which is a good news, and we were able to restore the same package versions. There were a whopping 20 modules in this Shiny app. Although they were using the older call module syntax while using uh, while the new way of using Shiny modules is to use the module server syntax, a challenge comes with having multiple R files is that when you source multiple R files, objects from one file can be masked and overwritten if the same object name is declared on another file that is being sourced. To avoid this, it is better to use a package that helps you to make specific exports from a file. In this case, the package used was modules package. We used to have a standard to use modules package at Appsilon before, but we've moved to box since then because uh, the ease of use of the box package is much better than modules. SAS framework to manage CSS was used, which is a great thing. But there was also a lot of unwanted .scss code, which is something that we would have to redact while we work on this app so that it's easier for us to add new CSS code. A single big SQLite file was making it hard to manage and deploy. There was so much plot related code that, but it was also distributed and it seemed to be doing same or similar thing. There was a use of global variables to manage state, which was hard to maintain and reason, making it challenging to work with reactivity in this app because the global object was also creating downstream reactive variables. This graph shows the time on x-axis and the amount of technical debt accumulated over the time since the project started in the y-axis. During the start of the project, anything seems possible. Any changes can be done, and they are easy to make. But over time, if enough tech debt is accumulated, the code becomes unmanageable and changes seem impossible or take too much time. Every time there is an opportunity to improve code quality and we push it to a later time, we are accumulating tech debt. Here are a few tech debts accumulated in this case. And we wanted to resolve every single one of them. And just to give a context, tech debt is not a foreign concept. It's been there for in other fields as well. Here are 3 generations of the Raptor engine of the SpaceX. Tech debt is not necessarily a bad thing. Sometimes uh, there are other things to prioritize, and taking debt to address on a later date seems like the optimal way forward. This is especially true in the early stages of the project, where the velocity and experimentation are more crucial. So it's quite natural to be end up with such a code base after a while. In this case, We addressed these issues by identifying the common logic across the app and understand how to remodularize this app. It became apparent that multiple plot types with slight variations were there in the code. So we decided to have separate plots subdirectory when we migrated to the Rhino framework. And once we migrated this to a Rhino framework after remodularization, the file structure looked something like this. The code is already organized in a way that makes it easier for someone new to contribute. Additionally, this simplified the reactive flow across the app. In the initial version, the state was set by session user data, which was creating downstream reactives, and it was challenging to know what's happening in the app. But after the refactor, the reactive flow was minimal and easy to interpret. And we also managed to resolve all the technical debt accumulated over the time. And new changes also were faster and uh, less cost in terms of time and resources. This was only possible because of the open source packages that supported us during the refactor. I highly recommend going through the Shiny Awesome extensions repository to explore packages that could complement your Shiny app. Final key takeaways. Try to look the code as a third person without context to identify gaps in documentation. Embrace modularity with Shiny modules and keep your code dry. Understand that tech debt is a natural part of development, but should be managed responsibly. And finally, use open source tools like Rhino, for example, to keep your code organized and scalable. Thank you so much for your attention. I'm happy to answer any questions that you might have on LinkedIn, or we also have a Slack community, Shiny for All. Yeah.
Okay, thank you, Vedha. That was a great presentation. So now I take a question from audience. If you have any question, please drop a question in the chat box. And in the meantime, let me ask a quick question. So it is great presentation that refers better programming practice to develop our Shiny as a team. So how do team manage the gap of programming skill? I mean the fundamental skill within a team. Any internal training support them?
So fun fact about the project case study that I mentioned is that once we migrated it to Rhino, it became much easier for the team members to learn these new skills. The challenge was not to have access to these tools in a practical way that they can work on daily basis. So I would say once you build one or two apps practically, you would actually gain the skill to master it. So it's just practice. So once we have access to these um, once we have access to these apps, uh, people automatically learn. Yeah, that's
Okay. Yeah, thank you. The great benefit from open source. And I don't see any further question from the chat box. So, okay, thank you again, Veda. Now let's close the session. Okay, hope everyone enjoy the rest of the session. Thank you.
thank you.
Have a good day.